let's get started today with a review exercise. Turn to page 15 in your speed drill and review exercise booklet. Page 15 in your booklet. And looking at exercise 17, we're continuing to build on what we talked about on our last exercise, where we talked about a form of investment, Scott, called stocks, right? And we said that when a person buys stock, the person literally owns part of the company, right? And so we would buy a share of stock, is what a piece of stock is called. Typically, a person will buy more than one share. A person might buy tens, dozens, hundreds of shares of stock in a company. And they have to pay a certain price for that stock. Do you remember what the price of a share of stock is called?
Quotation.
The quotation for the stock. So they pay whatever it is per share, but also they can't just go and buy it direct from the New York Stock Exchange. They buy through an agent referred to as a broker or a stockbroker, and they have to pay him a brokerage fee. Okay, and sometimes it's per share, sometimes it's just a flat fee, what have you. But they pay a brokerage fee, and then they buy the stock. Now, typically, the way a stockholder makes money is by strategically buying shares of stock and then selling off those shares when he believes, all right, I feel like this company's hit its highest value, it's going to hit for a while. Let me sell while it's high, but you buy while it's low. That's one form of making money. But it's also, as I mentioned last time, important to remember that because he's part owner, when the company makes a profit, so do all of the stockholders. Okay, so a stockholder is a part owner. Now, there's two types of stock. There's called common stock and preferred stock. The preferred stockholders get paid first. They're pretty much guaranteed that at the end of the quarter, assuming the company makes money, they get what's called a dividend from the company. The common stockholders get to share whatever's left over after the preferred stockholders have been paid. Come around this way. And so we're going to look today at the dividend aspect of things and looking at this as being a part of the company, getting to share in the profits of the company. So go ahead and get started now on exercise 17, there on page 15. Real quick, any questions at all? Front page was good. Back page. I think you lined it up over there and made your 40-degree angle. Remember, here, one end of B, put the 65. At the other end of B is where you put the 40.
Oh.
Right. And so that's how we should have finished it out. Otherwise, good. I was just kind of checking things off and marking little things for myself. Those weren't wrong. Just down here was the only problem. Any questions on that? All right. And then quickly, I was reviewing with Scott while you were coming in on this. And he actually heard most of what we were talking about. But a stockholder, because he owns part of the company, he can receive a dividend maybe at the end of the quarter or the end of the year from a profitable company. So they take all the money they've got, they divvy it up amongst the people who own the company. That's what we're basing exercise 17 off of. Let's go and take a look at these together. Neither of you able to finish, but we need to be moving on here. Number one, well, Mr. Billings owned 6 shares of Walmart stock, which again, these numbers are incredibly small to make them a little easier to work with, okay? So normally you wouldn't buy just 6 shares of stock, but that's what Mr. Billings owns, okay, from the previous problem you remember. While he owned 6 shares of Walmart stock, Walmart declared a quarterly profit of $72,000. Again, Walmart would normally make way more than that in a quarter, okay, in profit. But let's just go with that number. Now, since investors, remember, Mr. Billings isn't the only one, owned a total of 144,000 shares of Walmart stock. It was probably really in the millions, but whatever. Shareholders received a dividend of 50 cents for each share they owned. Does that make sense? $72,000 divided by 144,000 shares gives everybody 50 cents per share. Do you see that? Now, he owns 6 shares. How much money does he get? $3. 50 cents a share. 6 shares, $3. That's all we had to do there. Does that make sense? So the $72,000 was the big picture. This is all the profit they made. 144,000 was all the number of shares out there. And I even did the math for you and said everybody gets 50 cents a share. All you had to do is say, oh yeah, he had 6 shares. So the way you do this in the newspaper, in the money section, or as you look it up online, is what's the quarterly dividend? Ooh, 73 cents this quarter. Hey, I've got 50 shares. Let's see, 73 times 50 cents. Hey, I get $36.50 this quarter. That's how you would do it. You'd find out what the dividend is declared at the end of the quarter, and you're like, hey, I got this many shares. This is how much money I get. And then, of course, you're really, $3 is nothing. Right? $36.50 would be nothing. Where's the real money come from in stocks? It's not in the dividend. It's in selling off your stock when the prices are higher, right? But make a little money on the side. All right, the next one. A small business, Lana's Chocolate Factory, Lana Gourmet Chocolates, sold 40 shares of stock to some investors at a quotation of 30. How much money did the small business make from the sale of the stock? This was a little bit easier. What did we get? $1,200. Yeah, they sold 40 shares. Everybody paid $30 per share, so they made $1,200, which, again, how much can a business do with $1,200? Not much, but whatever. Okay, they've got 40 people who are now invested in or 40 shares invested in the company. That doesn't mean 40 people. Anyway, next one. If the small business declared a year-end profit of $900, which isn't much profit, again, these numbers are small on purpose, but if they declared a year-end profit of $900, how much of a dividend did shareholders receive for each share of stock? How many shares of stock were there, class? 40. How much money did they make? 900. So they have to divvy up the $900 by the 40 shares. How much per share? $22.50. There we go. So you got the last two, just missed the first one. Also last two, just missed first? Missed the first and the last, got the middle one. Does the last one make sense now? All right. And both of you seem to indicate the first one made more sense now as well. All right. So you have a little bit of an understanding of what's going on with stocks and stuff. Again, you may or may not invest in stocks when you're older. If you have money laying around and you want to, more power to you. I don't. I'm not. But, you know, it's good to know what's going on and how these things work. So that's part of the purpose of these review exercises, is review some things you learned in 7th grade that I don't want you to forget. And things that, you know, just practical math skills in the real world. Turn to your textbooks if you go to page 238. Page 238. And yesterday we just began barely delving into this concept of area. Area is, how would we define area, Lana?
Like the inside, like, the inside.
The stuff inside a figure, right?
Yeah.
The amount of stuff. Now, by stuff, there's actually a measurement we would use for this. How do I describe the amount of stuff inside? Scott, do you remember from last year, or maybe the last couple of years, really?
Square feet.
Well, square units in general, right? You'd subdivide this into a lot of little square units, so you'd find a particular size of something that fits evenly this way and that way. And you can divide it into a whole bunch of little squares, and however many square units are inside, that's the area. Now, when you get into slanty lines, it sometimes gets just a little bit harder. but it's still calculatable, we said. Because we said that if you were to take, for instance, a parallelogram, and just go straight down, you chop off a little piece. And because these two lines are parallel, you could then shift the little piece. And it would line up perfectly to make a rectangle. And we said for a rectangle, you don't have to count the number of little boxes. You can just see, well, how many boxes go this way? How many boxes go this way? And you would simply multiply. So we said yesterday that the formula for the area of a rectangle, Lana, is A is equal to BH. The base times the altitude, or the height is sometimes what it's called, hence the H. Well, the base times the altitude, or base times the height. Just multiply. Well, if that's true for a rectangle, then that's got to be true for a parallelogram as well, right? Because this is the same height, that didn't change, and even the base, we just took off this piece and put it there, so the base is still the same length, so the area of a parallelogram, then, Scott, will also be base times height. We said for a square, well, a square is a rectangle, isn't it? It's got perpendicular sides, doesn't it? Right? Now, it happens to all be equal, but they're still parallel sides, so the area of a square is also base times height, except, what do we know about the base and the height, class? They are the same. So rather than even specify, well, this one's the base and this one's the height, we could just say side in general, right? So it's side times another side, or we could say that A is equal to S squared, which is, again, it's just a form of BH. Looking at the triangle, we said if we were to take the same triangle, imagine if I could cut it out of the chalkboard and then flip it over and put this line up here, and this line here, and then this line here. Well, I would end up forming what?
Oh, wait.
Square.
Yeah.
Not a square, a parallelogram.
Oh.
And a parallelogram is BH. So a triangle, if you were to add it onto itself, would also be BH, which means that a triangle is half a parallelogram with the same base and the same altitude, correct? So therefore, a triangle would be A equals 1/2 BH. And we said that a trapezoid, if you were to draw something like this, well, here's the base, and there's the height. But right here, if you were to look at this one, kind of looking at it upside down, here's the base, and here's the height. But it's the same height, right? So we said that this is half base times altitude, this is half base times altitude, but the area of the whole thing is the half base altitude plus half base altitude. When you put it together, you end up getting that the area of a trapezoid is 1/2 the altitude times the
Two bases.
two bases
B1.
added together, right? The sum of the two bases, right? B1 plus B2. And so we have 1, 2, they're really the same thing, 3, 4, 5 different area formulas we needed for these special figures: rectangle, parallelogram, square, triangle, and trapezoid. Now, that said, if you were given a picture on a grid, like we were in number 1 on the homework, page 238, you could just count up all the little boxes and see how many little boxes were, just making sure this wasn't last year's. You could count up the little boxes and see how many squares are there. But Lana, this particular shaded area is a perfect rectangle. So you didn't have to count up the little boxes, did you? What did you do instead? Thank you. So number 1, you didn't count all the little boxes. That'd take you forever. What did you do, Lana?
I counted the base and the height.
Right, you just counted the base. How many boxes across?
22.
How many boxes up?
6.
So you said?
Like I multiplied them, I got 132 units squared.
Good, 132 square units. Very good. Number 2, Scott, you had a homework pass. You didn't have to do it. But how would I find the area of that rectangle? Base times height. The base is 20, the height's 12. What do we get?
240 feet squared.
Good, 240 feet squared, or 240 square feet. Number 3, Lana, it shows us that it's a square, and it gives us one side is 7.8 feet. Well, that means the other side's also 7.8 feet, so if we multiply base times altitude, or side squared, we get an area of
60.84 feet squared.
good, 60.84 square feet. Number 4, they give us a triangle. They tell us the base is 36 centimeters, and the height or altitude is 19 centimeters. Now, Scott, what's the equation that we would have to use on number 4? Right, a half base times height. Let me tell you what I'm not going to do. I'm not going to multiply 36 times 19 and then take half. I'm going to take half of 36 and multiply 18 times 19. It's the same answer either way. That's a lot less work, right? I'm a big fan of less work because I am lazy. Lana, what did you get? Not saying Lana's lazy. That wasn't the intended transition there. Because I am lazy. Now, Lana, what did you get for your answer on number 4?
342 centimeters squared.
Good, 324 centimeters squared. What is that shape in number 5, Lana?
Parallelogram.
And the formula is?
BH.
Base times altitude, good. And so the base was 3 3/4 meters, the altitude 2 2/5 meters. When you go to multiply though 3 3/4 times 2 2/5, you can't multiply mixed numbers. Class, we've got to change these to or decimals, one of the two. Now personally, I'm not a big fan of 3.75 times 2.4. You could, I'm not a fan. I'd rather multiply this way where I can do some canceling and I get a nice easy answer, Lana, of 9 square meters. You get the same answer either way, but I don't like decimals, especially not if the fractions cancel so nicely. Looking at number 6, what is that thing, Scott? So for a trapezoid, the formula again is right, so we're going to have to add the bases first. Now the bases are the bottom and top lines, 21 and 10. They're both called bases, even though it only sits on one of them. If you flipped it, it would sit on the other, so it could be a base. So 21 and 10 are your bases. We're going to add those to get 31. The altitude is 7, and unfortunately, I can't cheat and take half of one of these early. So I might as well just multiply 7 times 31, anyone, to get 217, and then take half, or divide by 2, of 217 to get, Lana?
108.5 square yards.
Good, 108.5 square yards, or 108.5 square yards, I suppose. We would not want to leave that as an improper fraction. Okay, remember in the algebra section I said we can use improper fractions? We ain't in the algebra section no more. We're in the geometry section. We want mixed numbers again, so good job on that, Lana. Now, number 7 is interesting because when you're dealing with an obtuse triangle, your altitude is measured from the highest point to the baseline. But an obtuse triangle, it's not over the baseline. So you'd actually have to extend the baseline out in order to drop the altitude here. So realize that for a triangle, if it's an obtuse triangle, your altitude may be outside the triangle. That's okay. So the altitude is the 22 inches, that's not a problem. The base is 31 inches, that's not a problem. That's not the extended base, it's just the actual base is 31 inches. Our formula for the area of a triangle, Lana?
1/2 BH.
We're now, again, it's a half times 31 times 22. Lana, what's the shortcut here?
Take half of 22, which is 11, and then just multiply
To get?
361 square inches.
341. 340. A little bit of a carrying problem there. 341 square inches would have been our answer there. Number 8. It says basketball court is 50 feet by 94 feet. That's a high school court. What is its area? And what did you get for that, Lana?
4,700 square feet.
Because we know that a basketball court is what shape?
A rectangle.
And a rectangle is just base times altitude, or you could say length times width. That's not entirely wrong. That's more what we'd be thinking here is length times width of the court. And we do get, as she said, 4,700 square feet. Great job on that one. Number 9, read that for us, Scott.
A garden is in the shape of a parallelogram with a base of 15 yards and height of 7 yards. What is the area of the garden?
All right, they told us it's in the shape of a parallelogram, which is a really random shape for a garden, but whatever. To find the area, we multiply.
Base times height.
Base times height or base times altitude. What do we get for the area?
105 yards.
Good. Squared. 105 yards squared, or 105 square yards. Number 10. Read this one for us, Lana.
Farmer bought a 60,000 square feet rectangular field for his livestock. The field was 300 feet long. How wide was the field?
Now here, they give us the area, the 60,000 square feet. They give us the length of the field, which could be base or altitude, doesn't matter which, and they ask for the width of the field. So if we'll remember that the area is equal to base times height, or it would be just as fine to say length times width, I know the area, so right here's where I'm going to plug in, class, the 60,000. It also tells me the length of the field was 300 feet. I don't know the width. So instead of plugging in L and W and multiplying to get the area, I plug in the A and the L, and to get the W by itself, Lana, you had to...
Divide by 300.
Now, the easy way to divide by 300 is to start by knocking off
2 zeros.
2 zeros. So it's really 600 divided by 3 to just get
200.
200. So the width of the field would be 200...
Square feet.
Well, area is square feet, width would just be 200 plain old feet. There we go, 200 feet for the width of the field. Questions on number 10. Number 11. Similar problem. Read it for us, Scott.
The area of triangle is 1 square feet. If its base is 5 feet, what is its height?
Again, start with the area formula.
A is 5 times b times 8.
But they start us off by telling us the area is 20 square feet. Equals a half times, do they give us the base?
5.
Yeah. But they don't give us the height here. Now, I could try to take half of 5, but that's gnarly, isn't it? I don't want to mess with that. This fraction is annoying, isn't it? Oh, I hate it. Ah, we hate it? What do we do with fractions if we hate them in equations?
You multiply everything
By the common denominator, which 2 is the only denominator. So the easy way here, instead of having to try to take half of 5 and get 2.5 and mess with that, just multiply both sides by 2, because you realize there's no plus or minuses. This is all one term. Okay? When I do, the 2.5 cancel to just give me the 5h. 2 times 20, class? 40. And now I'm just dividing a 5 to easily get h is equal to 8. Now, is it wrong to take half of 5 to get 2.5 and divide by 2.5 to get 8? No, it's not wrong. But you see how multiplying by the LCD, something we talked about earlier in the school year, can save us time and trouble? So these 1/2s, even if you can't do shortcut and just take half of something, can still be taken care of pretty easily. Should have gotten 8 feet for the height. Did you get that answer, Lana?
Mm-hmm.
Good. Did you happen to think to multiply by the 2, or did you just take half of 5?
Well, I couldn't figure out which way to do it, so I just
You made up numbers until it worked? That's another way to do it. It's very inefficient, but it does, it does eventually work.
sort of, I divide by 5 and then 4 and times 2.
Ah, okay, that's interesting. All right. So Lana said, forget the 1/2 for a minute. Divide by the 5 to get 4. So 4 is h. Well, not really h. It's a half of h. What's 4 half of? It's half of 8. She kind of figured it out, kind of in reverse, and that works essentially as well. Good. All right, a couple easy equations. Lana, we'll go rapid fire here. Number 12, z equals 3. Number 13, y equals
-5.
-5. Number 14, n equals
8.
8. And number 15, a equals 8. Good job there. Questions on the homework? Questions on the homework? All right, we'll turn back to page 233. Turn back to page 233. We're going to continue practicing with finding area. Didn't do a lot of practice. In fact, we didn't do any practice yesterday, did we, Lana? But talked about it, and then you just kind of on your own with the homework. A couple example problems I want to talk through with you very quickly. Letter A says find the area. First thing you have to do is figure out what shape you're dealing with, right? Well, obviously, 2 sides parallel, 2 sides not, plus that's a...
Parallel.
Trapezoid. There we go. Don't mimic him. Trapezoid, okay? And so you have to know which formula to use. You use the area of a trapezoid formula. And again, notice what they did. They got the 1/2 h times b plus b1 plus b2. They added the two bases, 3 and 13. Now notice that gives you 16. That's something you can take half of. So they took half of the 16 to get 8. 5 times 8, 40. Now again, if it hadn't been something to take half of, just finish the multiplication, take half at the end. But that works pretty well. Now, letter B. They give you it on a grid, but if you tried to count the boxes there and piece them all together, that would be really hard. Instead, just identify what shape you've got.
Triangle.
It's a triangle. How many boxes big is the base of the triangle?
4,
5. So it's 5 boxes big. So the base is 5 boxes. What about the height? How tall is the triangle? 4 boxes.
Yeah.
However, each box is not 1 square unit. 1 box is how big? Per the scale right next to the picture.
3 yards.
3 yards. So the base is 3 boxes, which means the base would be 5 boxes, 3 yards per box. Thank you, 15 yards. Yeah, don't listen to him. And I'm going to stop calling on you, Scott. You keep doing this to me. Lana, 4 boxes for the height would be how tall of a triangle? 12 yards. And then, once again, we come back to the formula. For the area of a triangle, class,
You equals 1/2 base.
good job, Lana. All right. Now you get 1/2 times 15 times 12. Let's start by taking half of the 12 to get 6, and then we get
80 or 90?
90.
90.
Yeah.
All right, 90. Now these were yards, so 90
Yards.
yards
Squared.
squared since it's area. All right, questions on the examples. Turn to page 235. 235. I want you to do 235, 236, numbers 1 through 4. Let's practice with some of these on grids. Page 235 to 236. Do 1 through 4 with gridded pictures. Make sure you account for the scale next to the drawing. Account for that scale that's next to the drawing. Let's go and take a look at these. Number 1, Lana, what did you get for the area?
100 square units.
Good, it's a 10 by 10 square. That's pretty straightforward. 100 square units. Number 2, Scott.
56 square units.
Well, there are 56 boxes that are full, but each box, it represents 2 units, right? So there's 2 boxes there, and so be 112 square units. Right, that's what it says. Number 2, each little box represents 2 units, correct?
Oh.
Okay, if each box represents 2 units, then it's not actually 8 by 4, right? It's, or am I counting that right? 7. It's not 7 across. The base is 7 boxes, which is 14 units total. And then the height is 4 boxes, but that's 8 units tall. So therefore, 112 units squared when you multiply base times altitude. Does that make sense?
I think I did it the same way, except I left it 28.
Okay. Because there are 28 boxes, but it's 2 by 2. So 2 units by 2 units is technically 4 square units in each one, right? It's 2 units, 4 square units, which is why you take the 28 multiplied by a 4. All right, let's look at the next one. It's 5 this time. So the base looks like, class, it is how many boxes?
4 by 7 or 7 by.
Is it 4 by 7? Is that right?
Yeah. 4 by 7.
Okay, I can't count. Sorry, it's hard to count there without actually making marks on it. 4 by 7. So it looks like 4 by 7, but if everything's 5, it's really not 4, but 20 by 35. But since it's a triangle, I don't multiply base times height. I take
1/2.
half base times height. Let's take half the 20 to get
10.
10. So it's really
350.
350 square, oh, it's inches, not units, excuse me, inches. 350 square inches. Do you see that? Not 5 units by 5 units, but 5 inches by 5 inches. All right, and then number 4, 3 meter little boxes. What shape, class? Trapezoid. So we're going to take half the height times the sum of the bases, right? So the height is 4 again, but times the 3, 12 meters, okay? The first base, the lower base is,
Wait.
I'm getting 10 also,
Yeah,
but
10.
by 3 is
30.
30, and then height is again 4, they're all seem like they're 4. By 3 would be 12, right? So 30 plus 12. Isn't it 4 boxes? Oh, excuse me, the other base, not the height, sorry, the other base. The other base is how long? I'm sorry, that's B2. Yeah, 6 by 3 would be 18. 18 plus 30.
Is
48. And to tell you what, let's just take half of the 12. 6 times the 48.
Is 288.
288 meters squared to be our answer there. Questions on those scaled drawings where there's a unit measure next to each of them? Kind of adds an extra dimension. Now, the rest of these on this page are pretty straightforward. Once you do 5 through 15, the odd. 5 through 15, do just the odd problems very quickly. And to tell you what, we'll have candy for the first one with all correct answers on 5 through 15 odd. So go fast. You don't have to show the work. Do as much work in your head as you want to. Since these are things we've known for years, I'm not going to emphasize writing out the formula each time. Let's see if you got them all right, though. That's the key. I don't think the people watching the video are done yet either, though, so we'll wait. It's okay, Lana, you're good. You're probably more representative of most people who would watch the video, so keep working. You're good. You ever seen those little motivational posters? They have like a one word and a pretty picture, like a definition or whatever, or a phrase. So I saw this one, it's elitism. It's lonely at the top, but it's comforting to look down on all those people at the bottom. The question is, are you really at the top? That's what we're going to find out when we check the answers. And God has a way of, when we feel like we're at the top, God has a way of humbling us too, so, yeah. I still think it's a funny poster. It's definitely how politicians view all of us. They're like, we're going to make these rules. We don't plan to abide by them. All you little people, we don't care about you. You're just a vote that helps give me the power that I rightly deserve. Anyway, all right, let's take a look at these. Number 5. Scott, what'd you get?
20 square feet.
That is correct, 20 square feet. Number 7.
16 square feet.
16 square feet. Number 9.
20 kilometers square.
Good. And by the way, I noticed he said 20 kilometers squared. Metric units are not square kilometers, for instance, but unit squared. You can do that with US units as well. So it's feet squared, but you have to do kilometers squared there. Good. That's not something we talked about yet. At least I don't think we had. Number 11.
330 millimeters square.
Good. 330 millimeters squared. Number 13.
189 square feet.
Good. 189 square feet or feet squared if you wanted to, just to make sure if you always do it the same way, you don't have to worry about forgetting which one's which. And number 15.
200 meters squared.
Got them all. All right, Lana, did you also get them all? Maybe not as fast. 200 meters squared.
How'd you get 200? I got 90.
90. Half base time.
I see what I did. I got half of 25 is 5.
Ah, okay.
Yeah.
And 5 times 6. Okay, gotcha. Yeah, half the 16 is 8 times the 25 is 200. All right. Other than that, got the rest of them correct?
Mm-hmm.
Go back into the evens now. 6 through 16. Actually, check that. Don't do 6 through 16 even. I want to move on to the word problems on the next page. I can't read. It says after the odds, do 17 through 20. It would help if I'd read what's in my notes. All right, number 17. Read it aloud for us, Lana.
Find the area of a triangular flower bed if the base is 10 feet and the height is 5 feet.
All right. At your seats. Go. Pencil down when you've got it. Good. Well, I was like, I just picked up my pencil. Gotta pick up the pencil quicker. Lana?
25 feet squared.
25 feet squared or 25 square feet. Good. Is that what you had? Read number 18, Scott.
A square has 6.5 inches size. What is the area of the square?
Go. Scott, what'd you get?
42.25 square inches.
42.25 square inches. Good. Lana, read number 19.
The area of a rectangle is 312 meters squared. If the length is 12 meters, what is the rectangle split?
All right, here we'll use the formula A equals LW instead of the BH. And again, we've got the A. We need the W. Go. And Lana, what you got for the width?
26 meters.
Good, 26 meters. So the 312 goes in place of the A. In place of the L, we have the 12. And we're looking for the W, so divide away the 12. And that's where we get 26 meters for the width. Great job. Number 20, read it for us, Scott.
The trapezoid-shaped plot of land has bases of 90 feet and 60 feet. If the height of the trapezoid is 110 feet, what is the area of the land?
First of all, I want to point out this trapezoid is taller than it is wide, right? Okay, usually we have these long, short trapezoids. This is a tall trapezoid, or perhaps a deep trapezoid coming back off the road or something. At your seats, go. All right, and number 20, what did you get for your answer?
8,250 square feet.
8,250 square feet is correct. Lana, good to go. Excellent. Any questions on these word problems? All right, we've got just a minute, 2 minutes. Let's give it a shot. 6 through 16 even, go. 6 through 16 even, go. We will do it if we have time. We've got time. All right, for sake of time, check the answers here. Number 6 should have been 18 centimeters squared. Number 8, 40 square feet. Number 10, 237 and a half, or 237.5 probably, square inches. Number 12, 20 and a quarter meters squared, or 20 and 1/4, or 20.25 meters squared. Number 14, 1.08 square yards. And number 16, a parallelogram, notice where the altitude lies outside the figure, 27 square inches. All right, did we get all the ones we did correct, even if we did not finish? And you were able to finish and got them right. Very good. All right. But you got all the ones you did right. All right. No homework this evening. Have a wonderful rest of your day, and you are dismissed.
My hands are working.